That's a bit better. All right. Quick background on me. I was a cognitive psychologist in Australia, so this is home for me. I'm now a lead data scientist at Booking.com based in Amsterdam. So this is actually the first time I came home and had no money, and it was very weird and very confusing. Very quickly, if you could, please introduce yourself to the nearest person or people, because I'm hoping everyone can sort of help each other out. So very quickly. All right, super important. All the material is available on GitHub, and including the data that we'll be using. So I did send an email out, but I know not everyone was there, and there's been a lot of movement around. So the first thing I want everyone to do is go find the material and get the data. So I'll guide you along as well. Easiest way to do it is go to github.com/DrSimonJ. See if I can bring this over here. Whoa, that's not what I wanted to see. You should see an awkward picture of me. Yep, there we go. So github.com/DrSimonJ. And the material I've pinned down here in the bottom right, Tidyverse tutorial, user 2018. So you get to something that looks like this. This is the repository. It's an RStudio project. So you can come here and click on this button and download the whole thing as a zip. You're welcome to do it like this. Also, all the data is in this data folder here. So there's 2 CSV files. If you have downloaded the whole directory, that's fine. You can unzip it and you'll have those files. You can also come here and click on these, and they take a second to load, and click on raw, which is just down here, and then you'll have this URL which we can use later. But anyway, as long as you found this repo, you will have data, and we will wrangle with it. That was super cheesy, wasn't it? Sorry. I don't do improv very well. All right. All right, so if you're having trouble finding that, please again raise your hand, and someone can come over and lend you some help. Before we dive into it, very quickly, what is the Tidyverse? So I assume everyone here has some idea, or at least they've heard the word Tidyverse and thought, oh, that seems to be sort of hot at the moment. I'll go do a tutorial on it, which is perfectly fine. This is off the website. The Tidyverse is an opinionated collection of R packages designed for data science. All packages share an underlying philosophy and common APIs. This has a lot of meaning once you get into it, but I think at first it's sort of hard to digest. So I want to take you through it a little bit. Also, do check out the website, tidyverse.org. So this is sort of how I think about it. It's a collection of open source R packages. Right? It's a collection of packages, like ggplot2 and dplyr, which are some that you're probably familiar with. It's developed primarily by a team at RStudio. I think I actually spotted some in the crowd. They're being a bit sneaky. But also very much by the R community at large. Right? It itself has a package called Tidyverse. And when you install it in R, which if you haven't already done, please do so while I'm talking, it will install all of those packages that form that collection. So it will install dplyr, ggplot2, tidyr, and so on. And when you load it in R, when you call library Tidyverse, it loads up the core set of packages. So there's many more that don't get loaded, and you need to call them separately. And we might do that now and then through the tutorial. Okay, so that's a tidyverse, right? It's just a collection of packages. Why do we need this opinionated thing with shared philosophy and common APIs? For me, ultimately, it's about increasing efficiency. Right? So by opinionated, it sort of means that it's forcing you to work in a particular way. And all of these packages all solve different problems, but they have a common interface. Right? So this down here is a workflow from a book, R for Data Science. It's open source. I highly recommend it. By Garrett and Hadley. There's the workflow. And they describe sort of typical data science workflows in this way: importing, tidying, transform, visualize, modeling, and communicating. You've got lots of packages in R designed for all these specific things. But what's been traditionally very difficult is the movement from one to the other, right? Going from data transformation to visualization. And by having all these packages sharing a common interface, it's like the glue, right? You can move through this workflow seamlessly without worrying about changing from matrices to data frames or lists or sort of going crazy, like trying to get the structures right. So in a way, it sort of restricts what you're doing, but so that it improves your efficiency and output. Okay, what will you learn today? There is an assumption, I think I put in the notes, that you know the basics of R, so I hope you understand how to assign variables. I assume you know what lists, vectors, data frames are. If you don't, or you're just a little shaky, don't worry, we can come and help you out as we go through. There's plenty of time to work through problems by yourself. So we'll look at exploring and wrangling with data. Pretty much all with data frames. The Tidyverse is very data frame centric. Depending on time, we'll look into repeating yourself efficiently. And throughout, we'll be tackling real problems using simulated data. I had to put that in, I'm sorry. All right. All these slides are in that repo as well from GitHub, so you can get all this. Let's dive straight in. So like I said, I work at booking.com. It's a travel accommodation website. And there we're really interested in understanding the ingredients of a great travel experience, right? And what we today are going to look at is exploring data about customer bookings and properties, right? So there's customers who come and book accommodation and understand what drives their review scores, right? What makes a good experience when you stay at a hotel or an apartment? Actually, this is where I'm staying. Please just come and say hi. You don't have to stalk me in any weird way. I'm very friendly. And so this is what we're looking at, right? The scores that people give to accommodation after they've stayed. Again, all data is simulated. So please don't take any of the findings literally. We're just going to play with it. All right, we're going to dive straight in. Please, I hoped everyone's installed RStudio. We're going to set up with RStudio and start a new project. Every time I've given this workshop, there's quite a handful of people who don't know about RStudio projects. So I'm going to show you on my screen, and please follow along. And if you know what it's all about, go for it. Go straight for it. One thing I think I should do here is definitely zoom in. This is equal. Is that better? Got some nods from the back? Excellent, thank you. So there's lots of ways to do this. You can go File, New Project. You can click on this thing over here and go New Project. And this will basically set up a fresh session for you, and it creates a directory. If you're not familiar, all it really does is create a folder with a text file in it. So I'm going to say New Directory, New Project, user tidy. You can call it whatever you want. I don't mind. And put it wherever you want. I'm going to put mine on the desktop. and create. And you'll see it do its little loading thing, and you get a fresh RStudio session. If I minimize this quickly, you'll see I get a new directory on the desktop. It's super tiny. You probably can't read it, but this is what I called it. And inside is this little text file, this rproj file. Right now, every time you open this project in RStudio, everything is relative to this directory. So if in the past, this is not Tidyverse related, but just separately, if in the past you're very used to using getwd, like get work directory, or setwd, you don't have to do that anymore. And it's advisable not to. All right, cool. And create a new R script, and let's light up the Tidyverse. So it's super nice. It tells you what packages it's loading into the environment. ggplot2, tibble, tidier, reader, per, dplyr. You might be familiar with some, maybe all of these. And like I said, there are lots more packages in the Tidyverse that don't get loaded up with this command. But we're going to stick to the main ones today. Bless you. Okay, importing data. So this is where you're going to need those CSV files we had before. You're going to want to put them somewhere that's easy to get in this RStudio project. This is purely the way I like to work. You can do whatever you like. I like to create a folder called data in my directory, and I put my data files in there. Whatever you do, I would just recommend sticking to something structured. And I have my data files here. I'm going to copy them into that data file. So if I'm in RStudio, I can see I have a data file and those two there. Again, just have them anywhere you're comfortable getting to. And if you need help, one of the guys walking around can lend you a hand. You also have those URLs to work with. So we have two data sets, bookings and properties. And the first package from the Tidyverse we'll use is called reader, which is for rectangular files. So here's an example of reading in a CSV. If you're familiar with the base R's read.csv, this is exactly like that, just way better. It's much, much faster, if nothing else. And you can make sure you can do this while I'm talking. You can read it in from a file that's locally on your computer. You can also read directly from the URL if you want to use the raw URL. And you should get something like this. Oh, this is a mistake. Call this bookings. So I'm going to pull this in here. Easy, right? You're now all Tidyverse users. Well done. And you can do the same for the properties dataset. So while you're reading those two in, I'll very quickly talk about what our datasets are about. Bookings, every row is a booking created by a customer. So we have a booker ID, an ID for the property that they booked, how many room nights they stayed, information about the price they're paying, what day they checked in, right, and so on. It's all about information of the customer's booking. The other data set, the properties, is one row per property. So we have a property ID, right, which we can match to the other data set. We have the destination or where that property is. Surprise, A bunch of them are in Brisbane. What type of property? Hotel or apartment? Number of rooms, facilities, so on. So of course, in this one we have one row per property. In the other data set, it's likely that we might have more than one row for each property because we can have multiple customers booking each property. Tibble. Who's heard of Tibble? Just quick show of hands. About half the room. Okay, cool. It's a cute word, if nothing else, and I'm not going to teach you much about it other than they're like modern data frames. So data frames are really fantastic, but they have a few hang-ups from the way they used to get used. And if you look at what has happened when you use this function, read CSV, and you look at the class of the object, you'll find that it is a data frame, just with a few extra things. So there's Tibble and Tibble data frame. For all intents and purposes, you can treat Tibbles like data frames. I might say data frame and Tibble interchangeably, right? I think the nicest thing as a user of Tibbles is how they print. And you can see it already, right? We get some really nice properties. A Tibble, okay, it tells us what it is. It tells us how many rows and columns. We can see the type of each column. It only prints 10 rows. And I can tell you where I work with massive data sets, when I forget and I print a data frame in the R console and it just goes right? It's the most painful thing ever. I'm getting a lot of nods. Everyone has this experience, right? And all you wanted to know was the column names, right? And then you scroll and then you're like, all right, that's right, there's the names function. Tibble solve all of this. It has a lot more advantages under the hood, but in day-to-day use, this is by far the biggest of them. That's all I wanted to teach you about Tibbles. So I'll say Tibble, I'll say data frame. They're definitely a core structure in the Tidyverse. Let's go into dplyr. So I'm very quickly show of hands, who knows dplyr? Most people, yeah, I think most people do. Not everyone realizes that it's part of the Tidyverse these days, but it is. And there are a few important things about it. Functions, is that, can you read that? Oh, wrong way. So the functions are verbs, right? Every function is a verb. Mutate, select, filter. The first argument is a data frame, and they return data frames. I'll come back to why this is important, but for now just remember data frame in, data frame out. Super important. Always the same structure in and out. Or Tibble, Tibble in, Tibble out, same thing. So the first argument is the data frame. Subsequent arguments reference columns. You do not need to use quotes. I think everyone knows dplyr a little bit, so you're probably familiar with these. I'll try and move through at a reasonable pace, but I do have to keep in mind that not everyone will know this. So we'll start with the basics. Select. Right? This function lets you select columns from your data frame. So here's an example. Select from the bookings, Tibble or data frame, the review score column. Right? So the first argument is the data frame, subsequent argument, column names. No quotations required. You get back a data frame or Tibble, whatever you had originally. So here we have a one column data frame. Very quickly, something I get a lot, because a lot of people come from other backgrounds or use other packages like data table. When I'm running this line here, this isn't changing the bookings data frame in any way. This is not in place. Right? So if you want to override or change your existing data frame, you can either override it like this. Please don't do this right now. We need the whole data set. I'm just showing you. Or you can create something else like X. And so X is now this new data frame. But one of the things I love about working with the tidyverse and these functions is you can really rapidly see what's going on. Right? So I can just keep running this and making changes until I get what I want, and then I can store that result. You can add as many column names as you want. Just keep going, go to town. There's no point adding everything. You can also drop. If you just want to drop a particular column, use the minus sign.
Sorry, when you said drop, does that mean that still won't affect your original data?
Yes, correct. It won't. That's a good question. So when I say drop, I mean it's going to be processed like that, so it's dropped this column, but it's not stored anywhere. So booking still has this booker ID column there, yeah. So if I want to really get rid of it, I have to do this. I get asked a lot about shortcuts, so I'm very quickly going to say if you want to, the hotkey for this is Alt or Option dash. You can go crazy with it. Okay, so we select columns and we filter rows, right? So these are the two sort of fundamental functions in dplyr that let you splice and dice. Filter, it's got exactly the same sort of setup. The first argument is a data frame, and subsequent arguments reference columns with conditions. So here I'm saying, hey, I want to filter this bookings data frame anywhere that status is equal to stayed. Right, so it drops, I definitely don't want that. Drops us from about 10,000 rows to a little under 8,000. And here you can use all of the operators used for logical, all the logical operators. So you have the double equal sign for is equal to. You have the bang or the exclamation equals for not equal to. You have in, is NA, less than, greater than, so on and so forth. Right, and you can just put as many conditions as you like. So this is anywhere status is stayed and review score is not missing, is missing. That's pointless. But you could do it if you wanted to. Okay. I think I'm going to skip this one. Everyone looks pretty comfortable. If you're not, don't worry. There'll be time to come back to it. This was just create a new tibble including room nights and review score where bookings cost less than 80 per night. I didn't put a currency because I'm used to thinking in euros and Australian dollars, and then everyone's got their own thing, so we're just going to talk in values. Right, so here we're saying filtering bookings, we get the price per night less than 80, and then we select these columns. And this is where I've created a new object X. Okay, Magritte. Maybe one of the RStudio people know how to pronounce this properly. I have no idea how to. No, I'm getting shakes. No one knows how to pronounce this properly, unless the creator is here. There's lots of things that this package does. There's one thing that I love about it, and that is the pipe. Why do you keep... That's this thing here, percent greater than percent. And if you see it, generally the person is working with Tidyverse packages whether they know it or not. And you may have seen this operator without seeing the package name, Magritte, because the pipe operator is imported by most of the Tidyverse packages automatically. So if you use dplyr, for example, you get this. You don't need to load up Magritte as well. What does it do? At first, if you're not familiar with it, it looks really weird and you think, why on earth would I ever do that? But I promise you, you will see the value. And if you don't, tell me later and I'll change the workshop. Too late, sorry everyone. So, say we have a function, f, and we have two arguments, x, y. We can write it like this. We can put the first argument on the left, pipe, call the function, and then add anything else. Right? So it's just, when you see this pipe, it's just saying, hey, the thing on the left is the first argument to the function on the right. So it just puts this thing over here, in here somewhere. That's all it does from a practical point of view. This one I'm going to use a lot in the workshop. Hotkey is Command or on Windows Control, Shift M. Command Control Shift M. Again, you can go crazy. Look at all these hotkeys, yeah. Trust me, you want the hotkey because you don't want to keep going Shift, % greater than %. It's a bit of a pain. So here's an example, right? I have a vector with the numbers 1, 2, 3, and I'm piping that into the function sum. And so it just puts this vector in here, and we get 6. Right? If I have other arguments, I can just add them here. If I want to look at the first 2 rows of the bookings data frame, I can pipe it into head and just say, hey, show me the first 2 rows. Too late, I put it up. A lot of people see this the first time, like, why? Why do this? I don't understand. I like to pipe for people. So what's going on here? Just have a think about it, see if you can work it out in your head. It's so quiet. It's awkward. So this is something you pretty commonly see, and I've been really nice here. I've aligned everything, and I cannot tell you the things in code I have seen that do this without alignment, and it's impossible to read as a human. So what we're doing, we have to read from the middle out, right? We're filtering the bookings data frame for everywhere price is less than 80. Then from that, we're selecting these columns, and then from that, we're looking at the first 2 rows. This is really hard to read, right? You often learn to code like this when you start, but it's super hard. Okay, so usually a solution is to do something like this. And you create multiple objects. So I'm saying X is filter this, and then X is select, and then head, blah. First of all, there's an error. I don't know if you can see it. Yeah? Yeah, that's it. I put bookings here instead of X. I should have used X. This is really common and very, very difficult to spot. In fact, when I created these slides, I made that error accidentally, and someone pointed it out to me. I thought, you know what, I'm going to leave it because it's a perfect example. The other thing I see a lot of people doing when they have a lot of complex stuff is like, X1 is this, and then X2 is X1, blah, blah, blah. And then you come along and go, oh, maybe you should change it up about here. And they go, X 3.5 is this, right? I mean, it's just how it is. It's complicated. This is what it starts to look like with the pipe operator. And also, if you want a sort of heuristic for how to think about the pipe, I read it as and then. So take the bookings data frame and then filter it to get price less than 80, and then select these columns and then look at the first 2 rows. I didn't need to create multiple objects. I can read it like a human. Yeah. So this is why I really like to use the pipe. All right, I'll give everyone a chance to test yourselves. If you're super comfortable, feel free to explore, or I can have a quick wander around. I'll just give everyone who's not a chance to try this. So write a data pipeline to get a tibble of the property ID and status of all bookings made on a Wednesday. So it's very similar to the example we just walked through. So the bookings made on a Wednesday refers to the check-in day. Thank you. Bookings for check-in on a Wednesday. I'm going to move on. There's lots of these little test yourself moments, and we've got a few challenges in here. Every time, please don't worry if you can't get to the answer. It's really just a quick check for you to say, hey, how am I feeling? Where are the gaps in my knowledge? And of course, I'll always share the answer with you. On this occasion, I forgot to put an answer. Whoops. Right, so very quickly for everyone. Whoa, that's stupid. I just need the answer here because I have the memory of a goldfish. Data pipeline, bookings. Okay, bookings, pipe. You definitely need to filter first. So check-in day equals WED, right? So that will give us all the rows with a check-in on Wednesday. And then we want the two columns, property ID and status.
Is there any reason why you need to filter first?
Yes, good question. Why filter first? So in this particular problem, if I'd selected these columns first, let me show you what happens. Error, object check-in day not found. So this is a really nice demonstration. These things are executed top to bottom. So we're selecting these two columns, which means check-in day no longer exists. So you can't filter on that anymore. Does that answer your question? That's a really, really good question, right? So it doesn't take your pipe and go, oh, I know what you're trying to do, and do some fancy thing in the background and work it out, right? It goes top to bottom. So if you get rid of, if you lose a column that you then want to filter on, it won't work. Okay, I think that I give you the answers to everything else, but if not, I will. Okay, ggplot2. I'm going to assume as well that most people are familiar with ggplot2, but very quickly, it's a seriously powerful plotting package. I can tell you I work in a community of a lot of data scientists who use all sorts of languages, and ggplot2 is definitely king when it comes to data visualization. Just a few details which most people will forget, so I'll rattle through them quickly. The API involves building a plot in layers. I like to think of it like those transparent plastic sheets, and you put down one, and maybe that's the background of the plot, and then maybe you put down some lines and then some points, right? And so it's always layering on top. And you do these layers with the plus symbol. It's got to start with ggplot, and the data has to be in a data frame. Visual elements like points, lines, bars, these sort of thing are geomes, and the appearance of them, like their position and their color, are defined by aesthetics. I'm going to just show you some really basic things here. Right? ggplot2 is insanely powerful. I'm going to give you like the 101, not even, like the day one of 101. So here's a histogram. ggplot, first argument is our data frame bookings, and here's where I define the aesthetic. So I'm saying the x-axis should be defined by the review score variable. And this sort of creates the background, and then I'm saying add, so I'm going to add a layer on top, geome histogram. And so this is how you create a histogram. I'll let the people who are typing very quickly get through it. I'm going to move on, but it's not too different. The next example. Here I'm going to use the pipe operator now because my screen got too narrow. So I'm saying take the bookings data frame, pipe it into ggplot. This time I'm going to define columns for the x and y axes. So x is the price per night, y is the review score, and geome point creates a scatter plot. So already we can start to see that there's some relationship between price and review score. It seems that the more expensive the accommodation, the higher the review, but it's definitely not a linear function, right? That sort of hits a threshold pretty quickly, and then getting more expensive doesn't seem to result in a better review score. Data is simulated. Okay. All right, I'm going to move on and you can have a chance to work through this yourselves. Whoops. Ignore the answer. So here's the challenge. Did you know ggplot2 objects store the entire data frame you provide it? Right? If you have a massive data frame, and often I do, and I want to save a plot and then start working with it, this whole thing gets stored in the object. It gets copied over. So this creates a lot of overhead. Sometimes it's just better to give it the data that the plot needs, right? You don't need all these extra columns and all these extra rows. So use a pipeline and create a scatter plot of the price per night against review score, which we did, but only for stayed bookings that lasted a week or more. And make sure to provide ggplot with a data frame of only the data it requires. Right, so you only need 2 columns and you only need rows where a stay lasted a week or more. And I've broken the answer up into chunks, so don't worry, I'll feed them to you as we go. Okay, it took a little bit too long. Answer part 1, if you're not there already, is filtering for the rows. Right, so anywhere where room nights is greater than or equal to 7, right, means the stay was a week or longer. Also, I put status equals stayed. So you don't need this extra step, but when the status was cancelled, there is no review score. So these are unnecessary rows. Part 2 is to select those columns. And then there's the last part, the plot itself. Yeah?
Sorry, I think I can get the same thing without this select statement.
You can,
Yeah.
definitely. I just wanted to sort of build in the pipe, and I had a good point up the back that actually maybe the select creates more overhead than the plot itself. But anyway, consider this a challenge in piping and dplyr. Was someone else, I saw a hand. No, you don't, no, you'll get the same plot without the select statement. Yeah. Yes? I would have said yes before, but I'm going to check this out later, actually. Yeah. I'm going to move on. Yeah?
This is probably an obvious one, but if you say use subset when you call your data frame, that would still have a big overhead because each block is still have a little data frame.
Again, I need to check this out. So I may have made a mistake there, but I will check it out. Actually, you know what? I'll come and chat to you later. Yeah. But for now, if you're comfortable with the piping and this, the dplyr functions in ggplot, right? These are really the essentials you need to slice and dice data and visualize it in the Tidyverse. Okay, I'm going to move on. Please don't hesitate to keep playing around with it. So what we cover? What did we cover? You might not have realized as we got to that last part, but we're using about 5 Tidyverse packages in that last part. In a human-readable way. Like I said, that pipe for people thing, I love it, right? Even if you show this code to someone who doesn't understand R or dplyr, they can usually get a pretty good idea of what's going on without having to read code inside out or anything like this. So we were able to import, transform, and visualize, right? And again, this is from that R for Data Science book. So we really covered this workflow seamlessly. And this is the value of the Tidyverse again, is you didn't have to think about the connections between these tasks. Just the Tidyverse lets you move through it really easily. If you wanted to go really crazy, I don't recommend it, but just as a ridiculous example, you could have started with the string of the data set and piped that into read CSV. Don't do this, please. I'm just making a point that you can do big pipes. Anyway, if you wanted to put everything in one pipe, I think that's a bit extreme. That's it. We dove in. All right, we're going to move on. Oh, I don't like seeing my face there. That's awkward. Dun, 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 slides. Okay, those were the real basics of dplyr. And we're going to move on to some more complex stuff. Also, very quickly, I have walked around the room and chatted to a few people. I noticed there are some people who are very comfortable with this material. If you are, I want to say, we'll get into tidyr. Pending time, we'll also get into a little bit of per. But I wouldn't expect really complex stuff. This is more for beginners to intermediate R users who are not familiar with the Tidyverse. So I'm not going to be at all offended if you decide, you know what, this maybe isn't for me, and head to another tutorial. I really won't be. So just for those people in the room. All right, we're going to focus a little more on this dplyr package. So you can set up by loading the Tidyverse, the two data sets. Hopefully you've done this already. And love the data transformation cheat sheet. It's not a command, but I suggest getting into it. So RStudio have this beautiful resource of cheat sheets. One of them is called a data transformation cheat sheet, which is all about dplyr. And if I open it up, you'll see something that looks like this. I want you to notice a few things. First is that there's a lot of stuff going on here. And this is the cheat sheet, right? So dplyr has an incredible amount of functionality. Like, it's really mind-boggling. The second, well, which is a follow-on, I'm only going to teach you like 5 functions, something like that. Right? So what you're learning today is really just a very small piece of a much larger and very powerful tool. Also, kudos to the RStudio team. I'm not saying this because there's some of them in the room. I say this at every workshop. They put a lot of effort into this stuff. I mean, it's designed, for example, for people who are colorblind. You know, this is why the color choice and so on. And these little icons that help you see, which obviously inspired the way I work, phenomenal. So do get the cheat sheet. You won't regret it. And I'm going to take my code. I'm going to cheat. Don't judge me. And we'll move on. Okay, recap. Select columns, filter rows. Hopefully everyone's pretty comfortable with that now. Mutate. You used mutate for old and new columns. So if you want to create a new column, this is where mutate comes in. If you want to replace or make a change to a column, this is what you use mutate for. So here I'm taking the bookings data set, and I'm mutating. The way it works is you put a column name equals, so you're saying, hey, this column, if the column name doesn't exist, it will create a new column. If the column name is already there, it will replace that column. Equals price per night times room nights. Right? So I'm creating a total price column per booking. It doesn't print out here, but you can see it down the bottom. Whoa. Right, so you can reference all the existing columns. You can do any sort of manipulation, apply any functions that you would normally do. Here's an example where I'm replacing an existing column. So say property ID, which exists already. It's currently a character or a string vector, and maybe I want to turn that into a factor. So I can say, hey, take this column and turn it into a factor. That's all there is to it. Why don't you try this one out very quickly, if you feel like it. So add a new column to the data set, which is the mean-centered price per night. Of course, I'd like you to use mutate. Okay, I'm going to move on just to keep the flow going. Yes, I did include the answer. I noticed someone already opened an issue on my GitHub repo to remind me to put the answer in the last one. Thank you to whoever did that. So here we're going bookings, take the bookings data frame or tibble and mutate. Create this column called centered PPN or centered price per night, where it's the price per night minus the mean of the price per night. Right? So this will set the mean to 0. Very useful for modeling. All right, summarize. So we're just going to power through some of these foundational things. Summarize. Takes many rows and returns 1, right? Many, many, many rows. It doesn't matter how many, and always returns 1 row. So here's an example. Say I take the bookings data frame and I summarize, and I want the average review score for the whole data set. I can say review score. If you look at it, it's very much like mutate, right? It works just like mutate. The difference is the value that you're assigning to this new column has to return 1 value, right? Because it's 1 row. So here I'm saying review score is the mean of all the review scores. I have to make sure to get rid of missing values, right? That's what this na.rm does. If you don't include this, you'll get a missing value back, na. And summarize returns a 1-row data frame. In this case, it's also 1 column, right? This is not a vector. This is still a data frame, just with 1 row. It's like teeny tiny 1 cell. It's very cute. Right? 1 column, 1 row. All right, here's something a little more complicated. Bookings, summarize. n equals n. This is a super useful dplyr function. It just counts the number of rows. You don't really use it anywhere. Well, you don't use it so much outside of summarize or mutate or filter. But it's very handy. So you can see this counted the number of rows for us. Right? And it's just like mutate. You can add as many of these things as you want. So now I want to say, well, hold on, how many missing values were there on the review score? So this is saying the sum of the number of missing values on this column. And then there's the mean review score again. And so you can keep extending this as long as you want. 1 row, 3 columns in this case. I'll just give people a few seconds to copy down some of this. Yeah?
Did you say you can use the in function within filters as well?
You can.
What does that mean? Would that, I'm trying to understand how what would you use that for?
Maybe if you hold on, I will come back to it.
Okay.
Yeah.
Cool.
I have some very good use cases for it.
Okay, cool.
Yeah. If you missed it, the question was you can use this n thing in filter, but why would you do that? And I will get back to you. Okay, if you hadn't already, you can test it out yourself, get a 1-row summary of the bookings data with the number of rows, so using n, number of stayed bookings, and the mean of the total price. I won't give everyone too long because I think you already copied down the last answer, but just quickly for those who are still working, and I'll just have a wander around if you need to pull me over for anything. So this time I built in mutate. So the first thing I did was mutate to add that total price column, and then summarize just as we did before. So the number of rows, the number of stayed bookings, and the mean total price. No missing values there, so we didn't need na.rm equals true. All right, group by. This is where we're going to start getting more into interesting stuff and where filter and n and all these things become useful. So let's say in our data set we have a column that says, I think it's is business, is business? For business, sorry. It's a Boolean column. And it tells us whether, when someone makes a booking on booking.com, they have this option to tick, I'm traveling for work. Right? So we know whether they're traveling for work or not, or at least whether they told us they are. And maybe we want to do operations or analyze these groups separately. And this is what group by helps us do. So the way I like to think about group by is it takes a data frame, and under the hood, puts each group into its own little partition or its own little world. And from that point on, everything you do happens separately in each little world. Right? Imagine almost like taking all the for business travelers and all the tourists and putting their data on separate computers and then running some operations on those two and then bringing the results back together. So very quickly, if you look again at the class of our data frame, this is what it looks like. It's a tibble, it's a data frame. Then here I'm taking the bookings data frame and I'm saying group by this for business column. And I'm saving it as a new data frame called bookings by type. You can call it whatever you like. This is just to show you. When you look at the class, it's now everything's the same except it's got this extra attribute called grouped data frame. But if you print it out, it looks pretty much the same, right? There's no, there's the same number of rows, there's the same columns, there's the same everything. You do get this extra little note up here, groups for business. Otherwise, you wouldn't really see any difference, right? So it's very much a change that's under the hood and waiting for you to do something else. If you're used to working in other languages, like SQL, for example, right, it does not collapse everything into one row per group automatically, right? It's just a change waiting for you. This is really powerful. Wrong way. Okay, so the natural thing to do is summarize per group, particularly, like I said, if you're used to working with other languages like SQL. So here we're taking the bookings data, grouping by this for business variable. So it's saying, hey, everyone that's traveling for business goes over here, everyone that's not goes over here, and then we're going to summarize on those two data sets. And so we're going to take all this data and return one row, and we're going to take all this data and return one row, and put them together, which gives us two rows. Isn't that convenient? So we get for business, false and true. So for everyone who did not tick, I'm traveling for work, there were 6,285 with a mean review score of 7.5. And for everyone who did travel for business, there's fewer of them with a slightly lower review score. We're really mean when we're traveling for work. Data is simulated. Right. What's happening here? Sorry, it went off the screen, but have a think about what's happening here. So I'm grouping by this thing again, so I'm putting all the business travelers and tourists in separate groups, and then I'm using mutate. Right? And this is, again, depending on your background and what languages you work in, this is a sort of unusual thing to see. I'm creating a new variable, centered review, which is the review mean centered, which we did before. The difference this time is that without the group by before, this mean here was the mean for the entire data set. So, right, it took everyone and subtracted the mean for that whole data set. This time, it's doing this operation separately for people who said they were traveling for business and not. So if we go back, it's going to take everyone who's not traveling for business and subtract 7.5. And everyone who is traveling for business and subtract 6.85. Right? So it's going to put both of these groups on a mean of 0. But people's position relative to 0 is going to be quite different now, because it's relative to their group. Right, and this is just showing, if I pipe this then into a plot, that both groups end up centered in the same way. So this is the beauty of group by. You don't have to use summarize. You can use mutate. You can use filter. And this is where the filter and end thing comes in. For example, say I have lots of little groups, like maybe I have lots of cities. And I only want cities where there's enough data to consider it useful, maybe 5 rows. So I could say group by city or group by destination, filter where n, with the brackets, is greater than 5. And that will get rid of any cities with less than 5 bookings. So that's where the filter and end thing becomes particularly useful. Okay, here's a little bit of a test. Reduce the bookings data set to only include the most expensive booking per property. You should get as many rows as there are unique properties. You should not use summarize in this case. Right, so you should end up with 4,178 rows. Okay, like I said, don't worry too much if you couldn't get to the answer, but if you gave it a try and sort of let this material sink in, that's the best thing you can do. So here's an answer to this problem. I'm taking the bookings data, I'm mutating to get the total price, grouping by property ID, and then per property, I'm filtering, say, where is the total price equal to the max total price. Yes?
How would this work if it happened that you had more than one booking that actually came out to the same total within a given company?
Yeah, so if you had more than one total price being the same, you would get both rows back. Yeah. So this is just like that example I was talking about before, where you can filter within groups, which is really powerful. So you can do things like, hey, give me the top 5% of scores for each group, right? Or like I said before, only give me groups with more than 5 rows or anything like this. It's a very powerful combination, the group by and filter. Oh yeah, just so you know, just like select, filter, basically all the functions that we're using today, you can group by multiple discrete variables. So we can group by for business and check-in day, right? So here I'm just getting the mean review score by every combination here. So for tourists traveling on a Friday, their mean review was 7.6. Happens to be high in this case. I guess tourists are happy on Fridays. I'm happy on a Friday. Little bonus, the function count is so sweet. I just see people not knowing about it, so I thought I'd throw it in. It's like doing a group by XYZ, blah, 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 and just summarize and count the number of rows. So if I take the bookings and I count for business and status, it's going to return every combination of those two variables and another column called N with the number of rows. So handy. Okay. Last bit of our dplyr journey are the join functions. These are when you have multiple data sets and you want to combine them in some way. Here I'm taking the bookings data set and I'm doing a left join of properties onto booking. So what that means is it will look for, the first thing here is it looks for matching columns. So we have property ID. So if you run this, make this a bit bigger, you'll see a note being printed saying joining by equals property ID. So that's if you don't include anything here. I do recommend, I do this in a commercial setting and I tell everyone I teach that they must add the by clause where you explicitly specify the matching column. But when you're working quickly, you can leave it out. And the left join means it will look for every property ID in properties that has a match in bookings. And it will bind all the columns of properties onto the other data set. I think I was pretty friendly and did it so that there are matches everywhere. But you'll see, right, once you've done that, so you see the booking data set first, and then towards the end you get the things like destination, property type, number of rooms, all the stuff that was contained in the property data set. And you have so much choice. Inner join, left join, right, full, semi, anti. Some of these, I keep forgetting what they do, but they're so useful. And if you are ever unsure, right, you run into this situation where you know you need to join data sets and you might have some requirements like you want the rows from this and not the columns from that, or whatever the case, they all have the same help page. So if you just ask for the help on any of these, like question mark, left join, go through the help page, they're all here, all with really nice explanations of what's going on. And so I'm not going to go through them all with you. You can take your time and go through them yourselves. All right. That's it for dplyr. Making good time. Either everyone's very comfortable or I'm going too fast. So we have a break in 15 minutes. Please come and tell me which bucket you are in and I'll adjust the second half accordingly. Data wrangling with Tidyr. Same setup as before. You might have already done it, so don't worry. We're also going to make use of a joined version of these data sets. So I'm going to take bookings and full join with properties. It will bind by property ID because it's found that, and I'm going to call this D. So that's full join. And while I'm talking, love the data import cheat sheet. Right, there's cheat sheets for everything. I feel like Oprah, you get a cheat sheet, you get a cheat sheet. Data import, data import. I think this one's a bit different from the dplyr one because it's not totally dedicated to Tidyr. So you have stuff on reader, which we use right at the beginning. If you've forgotten already, that's what we used for read CSV. It tells you all about the different uses there. You've got saving files. The second page has Tidyr. You have a column on the left about Tibbles, which is also really nice. And in here is all the Tidyr stuff. Again, there's so much stuff. It's so powerful. And I'm really just going to teach you a sliver of what it can do. Okay, this way. This is just one of the conveniences of Tidyr, handling missing values. The function drop_NA. Please don't ever use it like this. This will drop every single row with a missing value on any column. I mean, I'm not sure why you would want to do that. But if you're just trying to move fast and say, you know what, I hate missing values, just get rid of all of them, this will do it for you. If someone at my work did this, I would leave a nasty code review. It wouldn't even be that nasty. I don't know how to be nasty. This is probably how you should use it though. Drop NA and you name the column, right? You can see already it's a new package, it's solving different problems, but it's got exactly the same style of syntax that dplyr has. Right? You don't need to think at all about switching to new syntax or anything. So this will drop all the rows with a missing value on the review score column. Yeah, that's all I wanted to share. You can put comma and then add other columns just like everything else we've been doing. All right, reshaping data. Quick data munch, and as we're approaching the half time point, try this out. And I'll explain it to you while you're working. So the first thing I want to do, we're going to work with a summary based on check-in day. And it's a character vector, meaning if we would try to plot it or order it, it gets done by alphabetical order. Days of the week do not order by alphabetical order. I put Sunday first. If you're the sort of person who wants to get in a fist fight with me because Monday should be first, let's take it outside in the break. I've had some people get sort of passionate about that. Anyway, what I'm doing here is creating a vector that's going to let me order the days how I like to order them. You can put them in whatever order you want. I'm not a stickler. And then I'm saying check-in count. So I take my full join data frame D, and I'm counting every combination of destination and check-in day. So this is how many bookings were there on a Monday in Brisbane or Amsterdam, which is where I live. Then, in that count, mutate, and change the check-in day column to be a factor of itself where the levels are specified by that order. So now I know that when I order or I plot, I'm going to have the order of the days that I want. If you want to follow along in the next few parts, you'll have to do this. I want to move on because of time, but it's in the slides on the repo, which you should have, or I can also put it back up in the break, which is very soon. Right, so have a look at the data set this gives us. This gives us something like this. Destination, check-in day, N. How do I get to something like this? So you might be familiar with things like the reshape package. And there's lots of different ways to do this, but tidyr makes this super, super easy. And there are two functions that we're going to go through today, gather and spread. The first is spread. So it takes this sort of long format data frame or tibble, and it spreads those columns into a wide format. Right? So there's a key and a value. So one column has the names of the new columns to create, and the other column has all the values, and so it spreads them wide. And when you want to come the other way, so you want to take all the column names and put them in one column and all those values and put them in another column, gather. Gather goes the other way. And this is it here. So if we had that check-in count data frame, right, destination check-in day N, and I spread, and I say, hey, I want to take all those names in check-in day and make those new column names, and I want to take all the values in N and make those the values in the cells underneath. This is what I have to do, spread. So key, value. That's it. Doesn't get much easier than that. All right, what if we had to go the other way? So if we wanted to go from this sort of wide table and bring all this stuff down, I guess I ruined it in the picture before. It's gather. Right? So gather pretty much does the opposite of spread. The syntax is a little different because you need to think about what you're doing. Right? With spread, if I just go back, all these column names were the values that existed already. Right? So I don't have to name any new columns. But with gather, I have to create new column names. Right? These things don't exist yet. So when you use gather, these are the first two things that go into the function. The name of the key, right? The column that will contain all the old column names, and the name of the column that contains the values. Right? So key, value, these things come down here. You can call them whatever you want. And then you list out all the columns that you want to collapse into these two. Gather and spread. Challenge with 5 minutes to the break. No, I don't think so. So what I'm going to do is we'll start the second session from the challenge, and because by then you will have forgotten everything, and so it'll be super easy, of course. What I'll do is I'll leave this one up. If you don't have the slides and you just wanted to copy and play around with gather and spread, this is the data set we were using. And so it's 10:25 now. Well, it's a half-hour break, so if we could come back at 5 to 11, just so we have enough time for the second half. And we'll dive straight into the challenge then.